Thank you all for coming. I'm pleasantly surprised to see so many people here at 9 o'clock in the morning on a Thursday. But you're all obviously very, very interested in either what I'm going to say or Java in general. So before we kick off, my name is Mark Little. I'm VP of Engineering at Red Hat. I run the middleware and application services engineering efforts for Red Hat. I joined Red Hat in 2006 when they acquired JBoss. Some of you may remember there was a company called JBoss at the time. Over the intervening years, we've acquired other technologies like Fuse / Camel and 3Scale and quite a bit more. So we have quite a lot more than just the application server. I'm going to talk about Java. This is my personal perspective on Java. There's lots of things we could talk about in terms of the future of Java, way more than I could fit into a 50-minute slot with Q&A. So hopefully I'll touch on a few things that are of interest to you. Oh, there's still, yeah, right, did stop for a second. All right, so hopefully you all have seen or heard of Back to the Future. This is a scene from the end of Back to the Future where Doc Brown has actually come back from 2015. Anybody remember 2015 as being that heady day of the future where we'll all be flying around in cars and there will be no roads? Well, it's actually many years ago now, well, 7 years ago. And it's still pretty incredible, I think, to consider that today so much work is being done on Java. This is a language that essentially came out in 95. It was called Oak, then it got rebranded to Java, but with very few exceptions, C, C++ are probably a couple. This language has got such a pedigree now. It's being used in lots of different areas over the last almost 25, 30 years. And to think that people are still using it and still committed to using it, and there's still so much interest in it and innovation that's going on in the language and around the language, I actually think is quite astonishing and very good. Certainly for any of you who are using Java, it's a fantastic career opportunity. I will put my hand up and say, actually, by the way, Java is not my favorite language. It just happens to be one that has defined me for the last 20 odd years. If anybody is interested in what my favorite language is, you can grab me afterwards, but it's not Java. So just some quick statistics. You might have seen some of these. Obviously take them all with a pinch of salt, but I do find them interesting, hopefully to try and drive home what I was saying before about the fact that Java is still very, very vibrant. We've got GitHub statistics there, which they run very annually based on the millions of projects that are now hosted at GitHub. And then you have something called the TOB index. All of these are available online, so you don't need to take my word for them. I went back to 2021, I think, for TOB, but you can see that Java is in the top 3 these days, and it's been in the top 3, if not the top 1, for a lot of its history, which again I think if you look at some of these other languages is pretty incredible. So why is Java still important? Well, it's essentially the de facto standard language for enterprise developers. If you think about enterprises and certainly back-end systems, whether it's Netflix or Amazon or banking systems, even in air traffic control systems, a lot of what they have today is built on Java. It may be quite old versions of Java, unfortunately, but it's a lot of it is still built on Java, and we have a lot of Java developers in the world. But it depends on who you believe, Oracle or other independent statistics. But between 7 to 10 million people are using Java in one way or another today. Now, they may not be using it exclusively. They may be using it in combination with things like JavaScript or C++ or Rust, but they're still using Java. And if you look at where we are today with Java and the ecosystem, it's incredibly diverse. You only have to walk around the booths here, or to go to some of the sessions, and you'll see some of these vendors represented. Obviously, you've got Oracle and Pivotal and Red Hat and IBM. You've got Microsoft now. Microsoft is a big proponent of Java. And yes, those of you who've been around long enough will probably remember back in the late 90s, Microsoft was actually into Java then too. Visual J++ was the best Java development environment around about 98, 99 until they had a falling out with Sun. Amazon are into Java. A lot of Amazon's back-end systems, believe it or not, are actually written in Java. And obviously Amazon have their own Java OpenJDK build these days. In fact, there's probably more vendors, large and small, involved in Java today than probably at any time in the past. And I think this speaks to the fact that it's a very large and resilient community. We've had many waves in our industry over the years, whether it's service-oriented architecture, microservices, cloud, constrained devices. Constrained devices is essentially where Java came from originally, where some were working on something to run on washing machines and fridges and stuff. Java has managed to evolve and become relevant and remain relevant in many of those areas over the last 25 years. But one thing I think we often fall into, and I use we colloquially, I know I do at times specifically, when we often talk about Java and we talk about Java versus PHP or Java versus JavaScript, we're often comparing. We're not comparing like with like. If you've been in the Java arena long enough, you'll probably implicitly be thinking about more than just the language. We rarely compare just the language Java with JavaScript or with Perl or with Rust as a language. We're implicitly thinking about all these other things that have built up around Java, whether it's the IDE, whether it's the CI/CD systems, whether it's for better or for worse, whether it's things like Log4j, all these things that make our lives as Java developers so much easier. These are implicitly part of what we like to call Java. So when you think about Java and when you see anybody talking about, Java versus Rust, Rust clearly better, think about, okay, maybe on the language level, maybe there are some nice things in Rust that Java doesn't have, but if you step back and look at the productivity aspects of these languages, there are millions of people hours have been spent around more than just the Java language. And there's a lot of hours spent in the Java language itself. And we've got to remember that this is one of the things that makes Java very, very vibrant. And even if a new language comes along that on the surface of it, the language specs are far better than Java. What about all these other things that we're implicitly taking for granted? They're going to take a long, long time to be duplicated. And I think this contributes to a lot of where the innovation is. I'm going to touch on some of these. So there's innovation in the Eclipse Foundation. There's a lot of innovation still going on in OpenJDK, things like the faster release schedule. I think Holly Cummings yesterday touched on this a bit in the 15-minute keynote. And then we got Graal VM and Substrate VM, which hopefully some of you have heard about. So one of the things that's been driving innovation in Java, I would say for at least the last 7 or 8 years, is the transition to cloud and to microservices. So the diagram on the left, as you look at it, forgetting my left and right for a second, is your typical application server architecture of the day, late 90s through to 2010s. You got your operating system, you've got your JVM, then you have your application server. Could be Tomcat, could be something based on Java EE or J2E if you go back far enough. And then you have your frameworks that sit on top, things like Spring Framework. And then you build your apps. This was essentially what we were building, standardizing, and then what people were developing their applications on. And it did very, very well in those environments. Then, as I said, we saw cloud come along, and Java was okay initially in the cloud because lots of people didn't really know what they were doing there, I think. Lift and shift tended to be a good thing, and to a degree it still is today. But as we started to really double down on cloud development, and as things like microservices came along, that typical Java application server architecture started to creak and groan a bit, and people start to say, "Oh, it's a monolith. It needs to be broken down into microservices, and the JVM is just so big. It's a virtualized operating system. Why do I need a virtualized operating system on top of an operating system?" And this is when developers started to look at other ways of building applications, things that could spin up a lot quicker, things that had less memory footprint and could be crammed on small cores that Amazon made available. Now, it's important, though, to recognize why we had that traditional architecture, and it's still around today because it is still applicable to lots of use cases. We spent decades building the OpenJDK JVM and the application server technologies and the specs, the standards and the implementations of them that sit on top of it, looking at optimizing for throughput. We spent a lot of time making sure that these things would typically be spun up and they may not be spun down, ignoring crashes, for weeks, months at a time. So we needed to optimize for them running continuously. And this is where we started to look at things like OSGI, and the Wildfly has its own module system as well. We're absolutely optimizing for throughput. We're not optimizing for footprint. The original Java developers, essentially had this mindset of spin up the JVM. How much memory have you got? Great, give it to me all. I'm not going to get rid of it until I go away. And that gives you lots of flexibility and lots of performance in very, very good, very common use cases back then. And obviously, Java is very, very dynamic. Back in the day, before Java came along, people were starting to play tricks with dynamic link loading on C or C++ libraries to try and delay the binding of your interface to implementation till the last minute, because you wanted to delay these design choices. But it was hard. Java comes along and says, "Great, here's this thing called a class loader. Have at it. You can leave your bind choices till the very last minute, and your application server may have been running for 5 days before you actually decide which implementation you're going to bind to that interface. Oh, and by the way, if you want to change it later on, great, we'll do that." That does not come for nothing, though. There are overheads that are involved there, but we understand those trade-offs. Now, when cloud came along and Kubernetes, which has essentially become like the de facto standard for cloud, certainly for portable cloud, that has a very different approach. So clearly, Kubernetes uses Linux containers. Linux containers do not require you to be immutable. If you spin up a Linux container, you can modify and create a new container. Kubernetes doesn't work that way. Kubernetes assumes immutability because of the way that it works for load balancing and for failover. If you modify your container when it's running and Kube decides to take it down and spin up another instance somewhere else to make it fast, make your application faster, all those modifications have gone. So Kubernetes pushes you towards a more immutable approach to building applications. And Kube and cloud, we're starting more and more to think about short duration applications. Yes, it can be a lot cheaper to run your applications on the cloud rather than on back-end systems, but only if you remember to shut them off when you're not using them. There are many, many people, many horror stories out there of people who have literally, spun up their application, forgot about it, gone away, and a month later a bill comes and they've got like $2 million they've got to spend. I have actually got one person in my organization who did that 4 years ago. And he managed to spend quite a lot of money over a weekend that he didn't know about. So it's a very, very different mindset. So this notion of spinning up an application server and letting it run for 3 or 4 months, that doesn't kind of work in this environment. And I've already touched on this a little bit, but one of the things that we're starting to see lots of people using, and maybe some of you using it already, is serverless technologies, whether it's things like Amazon Lambda or Knative, for instance. Again, it's very event-driven. Message comes in, triggers an event. The event might say, spin up X to do some work. That work might then send another message, but when X is done, it goes away. Serverless is very, very important. Some people have talked about it as the evolution of microservices. But if you look at what people are doing on serverless, and particularly the languages or frameworks that they're using, and I have to admit, this is probably 2 or 3 years old now, it's not Java, or it wasn't Java. 63% of people are using Node.js, and almost 21% are using Python. Java is just, all right, twice as much as C#, probably twice as better as C#, but it's still just below Go, okay? And, essentially this is what I've just said. But if you look at what people have been trying to do at that point, and cramming all these applications onto the cloud, you can get a lot higher density of your apps in Go, a lot higher in Node, not as high as Go. And Node itself is higher than your traditional Java architecture. So if that had stayed the same, if that had not changed, then more and more people would probably have moved to Go or moving to Node. But like I said, there is a renaissance in Java, at least for the last 7 or 8 years, I think. And there's been lots of things that we have seen collaborated on by the likes of Red Hat, Alibaba, Microsoft, Amazon, and others around things like making the Linux container more aware of JVM. And vice versa. This is a two-way street. So understanding how the Linux container and JVM work in terms of memory utilization and processors. Again, many of you may not be aware of it, but you only have to go back 3 or 4 years to older versions of OpenJDK. And the Linux container running with a JVM of that time would not be able to give the JVM anything less than essentially all of the memory that it had available to it. And the JVM was not able to recognize the number of real processors that were running on the machine. We've made lots of changes, and that's a lot better these days. OpenJDK continues to evolve. You might hear almost every week there seems to be a new garbage collector. Shenandoah is a one that's hopefully pretty familiar to some folks, but relatively new and very, very popular, certainly with Red Hat people. Then we've got things like Checkpoint Restore that are happening in OpenJDK. There's Eclipse OpenJ9, which is essentially it's a white room implementation of the Java specs. It was done by IBM. It got donated to the Eclipse Foundation a few years back. They've been working on things like JIT as a service. So you essentially have a single instance which does all of your, which is the JIT, and it farms out bytecode, and you don't have to do that on the other servers that are actually attached to it. And then compiled, or as we're now starting to call it, native Java. Now, I'll talk a little bit more about this soon, but although it might sound like this is a new thing, it isn't a new thing. Native Java or compiled Java goes back, I think, probably till maybe 1999, early 2000s, there was a project called GCJ, which was essentially the GCC team, or some members of it, tried to work on adding Java compilation support to GCC, and that project was GCJ. Some of those team members then went and got involved with Java and OpenJDK. You may or may not have heard of Dalvik. If you're using Android and you've been using Android for a long time, you will absolutely have heard of Dalvik. If you haven't heard of Dalvik, but you have heard of the Google Oracle court case, that's all about Dalvik. So Google essentially, I'm no lawyer, so I'm probably going to paraphrase this or summarize it in a way that if I was, I could possibly get into trouble in the US, but Google essentially took a version of Java and they trimmed it down and they optimized it for running on a smartphone. And part of the Dalvik operation is to compile the bytecode to a native executable that runs on your phone. So you've got, that is essentially native Java. Then there were a number of projects over the last 5 years or so, Avian and something called Excelsior Jet. Both of those were doing native compilation. And then we have GraalVM. The thing about GraalVM that's very different to any of the ones that came before is, or at least there's a number of things that are different about it, and I'll touch on some of those later, but probably I think the one standout thing that makes it potentially more successful is it comes from Oracle as well. So all of these others had to worry about, I don't know if there's any Oracle employees in the room, so if there are, please put your fingers in your ears. They had to worry about being sued by Oracle for infringement of one thing or another. That team shouldn't, because they are Oracle, okay? So it has more of a chance of being around for a few more years. A lot of this stuff here, well, all of this stuff is improvements at the JVM level, which are incredibly important. However, as I'm about to talk to you, improvements at the JVM level, while they're necessary, they're not sufficient. And some of this, or at least they're not sufficient for when we're, again, thinking about things like the cloud and Kube-native. It comes down to what I was touching on earlier about, the traditional 20+ years of designing and building and architecting and building Java applications and certainly Java application server applications. This dynamic aspect of Java, even this dynamic aspect of the application servers, allowing you to do very late binding of your JMS implementation, for instance, and then rebind it later on. All of that essentially can be encapsulated in this, where there's some build time aspect to developing your application. But a lot of the work happens at runtime. So, build time, obviously, before this, there's the writing your application, and that could be months here. So that's not represented on this slide. But once you get to that point where you can compile, you're working with Maven, you might be working with Gradle, but you do a lot of that work on binding at runtime. So you might load configuration files. Obviously, you do class path scanning. And you can be doing this continuously through the long-running life of your application. And as I said, OpenJDK or the JVM in general and the frameworks, the stacks that we built on top of it have been optimized for this. But there's still a lot of work that's involved in this. There's still a lot of infrastructure or baggage, if you like, to make all of this work. Some of it's in the JVM. A lot of it is on top of the JVM. What we're finding, though, for Kubernetes native is we're trying to flip it around. As I said, Kube kind of pushes you towards a more immutable approach. If you change the application, what Kubernetes would require you to do is change your Linux container image and stick it in Kube's equivalent of a repo, and then Kube can pull that out. Do not change the existing image because, like I said, it's going to get rid of that. It's ephemeral. So put as much of that previous work that was done at runtime at build time. Make those decisions at build time. make this as quick as possible so that if you do decide to change your JMS implementation, probably doesn't happen that often, but if you do decide to do it, you can rebuild your container image, stick it in the Kube repo, and hopefully that's no more than a few minutes. And then very little actually happens at runtime other than the business that your application should be doing. That could be, reserving a restaurant seat or, flight booking system, whatever. So there are a number of frameworks and stacks these days that are said to be Kubernetes native. Obviously, the one that I would like to point you all at, and I think there are some slides, some other presentations, you can go to the Red Hat booth, is one called Quarkus. Quarkus 2.9 is now out for those of you who are really interested in it. But we have spent a lot of time optimizing Quarkus and the frameworks and implementations that it uses, some of which have been around for decades, to be Kube native. And I say I'm not going to spend a lot of time on this. But what we have managed to do is, some of you may have seen some of these before, but essentially we've managed to take startup times down, in some cases from over a minute to 400 milliseconds. Now, I want to just point out there are 3 graphs here for a very good reason. A lot of the time with Kube native and certainly with Quarkus, we tend to focus too much on the native aspect, the Java native, the compiled with Graal. However, that absolutely does help, but we've spent a lot of time making sure that a lot of these build time decisions, well, the runtime decisions that you were making that we then shift to build time, they happen irrespective of whether you are going to use Graal or Substrate. They happen even if you're going to just use vanilla JVM. So that's why we have these 3 graphs here. So I won't spend too much time on this, but in here you've got reduced memory footprint is what we're focusing on. You've got your traditional cloud native stack. So that could be that architecture that we saw earlier. So it could be Tomcat, it could be an application server, it could be even Spring Framework or Spring Boot could be on that. But that's your traditional. The memory footprint there is 136 meg. Because of all this stuff, it's leaving to runtime. It still has to have there available, even if you're not going to use it. Just optimizing that and doing ahead of time decisions, so at build time, this is the JVM. This is still the JVM. We get that image size down by almost 50%, 73 megabytes. Then if you add in the compilation, that goes down to 12 megabytes. So I just want to point this out because you don't have to use native Java if you don't want to get some of these performance improvements. This has then shifted that diagram that I showed you earlier. So you've got Node, you've got Go, you've got Node, and you've got your traditional cloud native stack. Then you've got Quarkus in there. And quite literally we've had, from a Red Hat point of view, and there's some success stories that back this up, but we have had big customers of Red Hat who 2 years or so ago, when we started to really push Quarkus, come to us and say, we were on the path to rewrite everything in Go or to rewrite a lot of it in Node.js, and we're not going to do that now. We're a 6,000 person company. We've got 500 to 1,000 Java developers who we have spent years training to be Java. It was going to be a monumental task for us to go from Java to Go. And now that we've seen what you can do with Quarkus, native Quarkus or not native Quarkus, we've decided that we want to stick with Java because essentially this is still Java. You are not having to change the way in which you develop too much. If you want to take advantage of some of the capabilities, you do have to make some changes, some mental changes around things like reflection, for instance. But generally, you can just take the skills that you know and you can get that improvement. So I mentioned this a few times, but one of the key aspects to that native performance improvement and memory footprint improvement is this thing called Graal VM, or very specifically Substrate VM. So Graal is a huge project. If you haven't heard about it, you should go and look for it, Google it. It'll definitely be in your top hit. It does a lot of different things. The one subcomponent, if you like, that we're really interested in is the native Java aspect. So that's what is in red here. So that's, includes things like Substrate VM. I think I've touched on some of this already, but if you think about JIT and versus AOT, with Hotspot, again, high memory density requirements, grab all the memory that you possibly can. Fast startup time. The JVM starts up pretty fast these days compared to what it used to do. So it's certainly not in the ballpark of it was a decade ago. It's still fast, or it is faster, I should say. Sorry. You still get the best performance when you are running your applications on OpenJDK versus Graal. There are trade-offs that happen under Graal/Substrate that we absolutely want in some environments. Like I said, memory startup, memory footprint, absolutely. But if you are going to be running your application for a long time, let's say for more than a few minutes, you should still think about OpenJDK. Absolutely, because it has been optimized. It has been optimized a lot to make those applications faster. I'm not suggesting you go back to the old model of leaving all of your design time choices to runtime. I still think you should make a lot more choices, if you're thinking about Kube at least, at build time. But OpenJDK offers by itself some significant performance improvements for long duration applications. Serverless, it's a completely different story. You can do serverless with OpenJDK, but you have to play some tricks, and it's not necessarily as performant, and it certainly doesn't hit the memory footprint. Obviously, there's a lot of other things that come with OpenJDK that aren't available with Graal at the moment. Things like, so mission control and flight recorder are kind of there. But a lot of the monitoring tools still haven't been ported across. That is work that is going on. And this is probably the point I would like to make. Graal, despite the fact that Graal has got a lot of popularity at the moment, it's still quite new. It's still a research project. It's in Oracle Labs. It's not actually Oracle, the product side of things. There's a lot of research and development still going on here. So it may not have some of these things now. I guarantee you, if it continues, it will have them eventually. So I think Graal actually has been a great catalyst for innovation in the space of Kube-native Java. Red Hat had, just in case anybody has heard about it, Red Hat has a version called Mandrill. It is part of the Graal ecosystem, so it's not a fork, but it is a fully supported version. So Oracle, with Oracle Labs, have essentially two versions of Graal. There's Graal Community Edition and Graal Enterprise Edition. You get no support for Graal Community Edition. It's community, best effort. Graal Enterprise Edition, to get that, you need to buy, I can't remember if it's a license or a subscription, but essentially that you get that support from Oracle. So Mandrill, from a Red Hat point of view, if we have any customers who want to use Graal in production, there's two choices. We either point them at Oracle to get an Oracle Enterprise Edition license, which we would never ever do, or we recommend that they go and get Mandrill, which is our fully supported version, because our OpenJDK team and others have been working with the Oracle team for a number of years upstream, so we can support this. It's pretty much the same as what we do with other upstream communities where we collaborate with the likes of Microsoft. It's no different really to what we do with OpenJDK. But Graal, as I said, is this one implementation that comes from Oracle Labs. There's no standard. It is effectively the de facto standard at the moment. But one of the things that concerns various people is it's not necessarily a fully open source project yet, but it's just from Oracle. Yes, Red Hat's involved with it. Yes, there are some folks from Twitter are involved in it, and there are a few other vendors who are involved in it on the edges. But it's outside of things like OpenJDK, which has got a huge community of contributions. Like I said, Amazon, Microsoft, Alibaba, to name just a few. So what was announced last year in the OpenJDK project was a project called Leiden, or Leiden. I never know how to pronounce it. And essentially what Leiden is going to do, if it ever comes out, is try and provide a standard within OpenJDK for native Java. Graal needs to fit into that somehow, and it may well be that Graal is an implementation of whatever Leiden does, but it shouldn't necessarily be the only implementation. So things like, for instance, OpenJ9 from the Eclipse Foundation could provide their own implementation. For anybody that's interested, there is another project in this space called Kubic, and there's a URL there. Kubic is absolutely a research project from Red Hat. Some of the people who've been involved with the Graal efforts for a while, trying for the last few years to do an independent native Java implementation based purely on Java as well. So that's there if anybody's interested to take a look and try it out, maybe even contribute. So I wanted to move on a little bit though to something called Eclipse Adoptium. Again, in this context of innovation in Java. Hopefully you'll have heard of Eclipse Adoptium. If you haven't, you should have heard of Adopt OpenJDK. That was its old name before it got moved to the Eclipse Foundation. And Adoptium is a great example of how naming is still the hardest problem in computer science. But it's essentially the same thing, okay? So it's high-quality OpenJDK binaries that are built and tested by a community of vendors and individuals. You've got Alibaba contributing to it, you've got Azul, Huawei, IBM, Red Hat, all these vendors and more are part of the Adoptium working group. And there's actually more there who now than were involved with Adopt OpenJDK. Part of Adoptium is also something called Aquavit, which I'll touch on in a minute, which is a test suite, and there's a branding and certification that goes around there. And all of this is open source. Should keep saying that. Everything is open source here. Nothing is closed source. Nothing is proprietary. And then we have something called Temurin, which is the official name for the builds that come out of Adoptium. I don't know. Hey, you can see these. Great. So I just wanted to flash up some download statistics, just in case you haven't seen it. If anybody can remember, when Adopt OpenJDK came out, the main reason that IBM and the London Java User Group, who were the original creators of it, formed it was that there was no central place that any developer could go to get a definitive implementation of OpenJDK binaries for their architecture. You could go to Red Hat. You couldn't go to Microsoft at the time. You could go to maybe Ubuntu or somewhere else and get a version of a binary. And in many cases, they were binaries that were months, if not years, out of date. They were binaries that had not been patched for CVEs. They were absolutely, it was almost a Wild West. There was a big gap in the market here, and I don't mean market from a revenue point of view, because these are all free. And they got together to create a central repository where you could go, and like I said, you could get binaries that you could trust. Okay, and Adopt OpenJDK in 5 years, let's call it 390 million downloads of Java. That is predominantly OpenJDK builds. Yes, there's some OpenJ9 builds in here too, but it's mostly OpenJDK for various architectures. Adoptium has been up for about a year, and even in that time, 27 million downloads of various architectured versions of OpenJDK. So lots and lots of people going here, and I would encourage you. If you need to get a binary, these are predominantly unsupported, but if you need to get a binary for your developer situations, go to Adoptium, go to the Eclipse Foundation, and get involved. So yeah, so I think I've probably said some of this, and only 12 minutes left. But the important thing is that these are all, well, mostly in Adoptium, they're all based on OpenJDK. There is no OpenJ9 builds in Adoptium. Yeah, they were on Adopt OpenJDK, but they're all based on the upstream version of Adopt OpenJDK. There's nothing proprietary in any of this, and they, as I said earlier, they pass this test suite Aquavit, which we'll touch on in a second. But every binary that you find that is released and given a equivalent of a GA tag has gone through this certification process and has had CVEs applied to it. These are updated on a daily basis whenever anything significant comes out, like Log4j. Did I have that? Oh, okay. So I must have missed the slide that I had on Aquavit. So I will say a little bit about Aquavit. Aquavit is this test suite, over 250,000 tests that have been developed to put these binaries through. It is not the same as the TCK. If any of you are involved with OpenJDK or any of you know what the TCK is, it's essentially that. It's a test compatibility suite that Oracle controls, and anybody who wants to have a distribution that is called Java has to pass the TCK. So if you can remember that Dalvik reference a while back, that never passed the TCK, despite the fact that Google were then calling it Java. But the TCK tests some very low-level capabilities, very, very low level. And in many cases, it doesn't test the things that developers use. And there are areas where your JDK, or your JVM, I should say, can fail, and it would still pass the TCK. And the TCK wouldn't be updated because the idea is the TCK only tests this very small subset of capabilities. So Aquavit was developed to try and address a lot of these situations where the TCK isn't applicable. Like I said, over 250,000 tests are run on every single one of these binaries, and that in itself is an evolving project. So any issues that get seen around OpenJDK that aren't things that would get covered by the TCK, this team gets together and adds more tests. So Aquavit is itself growing. And actually, I hope at some point Aquavit would become the brand that you would look for more than something that is TCK'd. Because I think from a developer point of view, Aquavit is probably going to have more relevance to you in your day-to-day application development lifecycle. So something else I wanted to mention, which is not in the Eclipse Foundation, but it is another open source project, is something called AutoTune, or Cruise AutoTune. I'm sure if you're in the Java business, whether you've been in it for a year or you've been in it for 2 decades, you will have probably spent some time trying to tune your application. This is not necessarily tuning it for the cloud or tuning it for Kubernetes. It could just be tuning it to run on your backend systems or tuning it to run on your laptop. Tuning the JVM is in many ways a mystic art. It's something that could have been taught, by one of Harry Potter's teachers. And then when you think about tuning the applications that sit on top of it, it can get even more complex. So if you look at Red Hat, for instance, or Microsoft, you will typically find a lot of the documentation that comes out is about tuning. In this environment, with this capabilities, and this, these are your requirements. These are the parameters that we suggest that you take and you put to the JVM when you run your application. A lot of time spent on this. What AutoTune tries to do is to do this for you automatically using AI machine learning. Yes, I know you think, oh God, machine learning. Yes, that's never going to work. But AutoTune actually does work. And the team behind this have been pretty pragmatic in, first of all, admitting the initial tuning parameters that AutoTune might come up with might not be the optimal ones, but it monitors your application at runtime, and it can continue to keep tuning it and making some modifications to the performance. And like I said, this is available as an upstream project. It's not specific to Kube. You can use it with Kube, but you can use it with any OpenJDK application, with any application that or framework that's sat on top, whether it's Spring Boot or Quarkus or Wildfly. But I think it's extremely innovative, and it's probably one of the real world use cases of AI machine learning that I think is going to be around for a long time and hopefully make your lives easier. Say a couple of things on frameworks in the Eclipse Foundation again. MicroProfile, been around since 2006. Lots of activity in this from these vendors here. It essentially span out of Java EE at the time in 2016 to try and focus on microservices and take this notion that, well, Java EE is a monolith. You don't need all these 45 specs. Let's start with 3 specs, and let's rapidly innovate in this area. Because Java EE never rapidly innovated. One release every 18 months was probably way too fast. And in the 6 years since it's come out, there's way over 20 releases. It's won a Duke's Choice Award. There are lots of new specs that have never found their way into Java EE, but were influenced by things that were happening elsewhere, whether it's Netflix OSS, for instance. Stuff that was happening in Spring Boot have influenced what goes on in MicroProfile. And there are lots of implementations there. And it's, like I said, it's still going today. And if you're interested in enterprise microservices, take a look at MicroProfile. Jakarta EE, that is the new name for Java EE. Oracle essentially decided to donate all of this to the Eclipse Foundation in 2018, 2019. That's kind of still in a getting up and going mode. The aim behind Jakarta EE is in some ways similar to what MicroProfile is trying to do, to trim down and provide more cloud-native implementations. And there's an overlap in the participants. So at some point, these two things, they are collaborating, but what their futures are, who knows? But again, I put this here as it's a great example of how the Java community is still trying to innovate and still trying to tackle these problems and build on the knowledge that has helped evolve Java over the last 20 plus years. So this is kind of like my conclusion slide. I hopefully have given you, like I said, my personal preferences on innovation that's happening in and around Java. Things like OpenJDK and GraalVM, all the work that's going on in Adoptium. I think that that's really critical. And then stuff that Red Hat and is doing with our partners or by ourselves. VS Code extensions, for instance. If anybody isn't using VS Code, you should absolutely take a look at that. I was doing a Microsoft conference last week, and the guy from Microsoft I was talking to at the time was saying that on a daily basis they get something like 1.5 million downloads of the VS Code Java extension, which is incredible. So this is my conclusion slide. I think there's a huge amount of innovation happening in Java today. In terms of cloud native and Kube-native, I definitely think Java has stepped up to try and address this problem. If you're looking to modernize your applications, your Java applications today, you should obviously think about trying to make them Kube-native. Doesn't mean you have to use native Java. And if you do go to the native Java side of things, though, there's a lot of opportunities now that we're seeing opening up around reactive and serverless, and even far edge constrained devices. Like where Java started, it's kind of getting back there now. And I started with a Back to the Future slide, so I'm going to end with a Back to the Future slide. I think hopefully, with people like yourselves involved in one or more of these efforts that I've talked about, Java's got a bright future. Thank you very much. We've got time for a question, or you can grab me afterwards.